Okay, let's dive into this. We're talking about a number that just kind of stops you in your tracks. $500 billion.
Yeah.
500 billion. I mean, just for context, that's more than the GDP of, well, quite a few countries. This isn't just a big investment. It sounds like one of the biggest infrastructure projects ever in tech, period.
It really is staggering, and you're right to hit that number hard up front.
Hmm.
The sources we're looking at today call it the Stargate Project, and it's this huge collaboration, really unprecedented, between OpenAI, Oracle, and SoftBank.
Stargate,
Yeah.
okay. And the mission here is what? Just building bigger data centers?
Bigger is an understatement. They're aiming to build the world's most powerful AI infrastructure. And it's not just for, faster websites or cloud storage.
Right.
This is specifically built for what are called frontier models.
Okay, the really advanced AI stuff.
Exactly. The most advanced general-purpose AI systems out there. And yeah, the ultimate goal is pushing towards AGI, artificial general intelligence.
So a platform for potentially creating true AI.
That seems to be the ambition. So our deep dive today is really about figuring out how this coalition thinks they can pull off something so enormous.
Yeah, how do you pull that off?
We need to look at the sheer physical scale, the capacity they're aiming for, how these partnerships actually work together.
Right.
And, maybe most importantly, what does it mean for the world if one group controls the key resources for building future intelligence? We're kind of moving past theory here.
Yeah, this is steel and concrete and power lines, the physical reality of the AI race.
Exactly.
Okay, let's start right there then with the physical side because these numbers are just mind-bending. We've got the headline figure, around $500 billion projected cost. What does that actually buy in terms of capability?
Well, the big target number that jumps out from the sources is 10 gigawatts. 10 gigawatt of power capacity.
10 gigawatts. Okay, help me wrap my head around that. How much power is that really?
So think about a modern nuclear power plant, a big one. That typically generates around, say, 1 gigawatt. So they're aiming for the equivalent power output of 10 large nuclear reactors.
10. Wow. Okay.
Or, put another way, the sources suggest 10 GW could power several million average homes. That's the kind of scale we're talking about. That's apparently the new baseline for serious AGI compute.
Nation-level energy demand. Yeah, that context is crucial. And this isn't some far-off dream, right? That sources say they're actually moving on this already.
Oh yeah, there's a real sense of urgency here. That's the whole compute race idea.
Right.
The sources are talking about immediate plans for 5 new U.S. data center sites. Like they're being unveiled now.
5 new sites just to start.
Just to start.
Yep.
And these initial sites alone are supposed to add about 7 gigawatts of compute power towards that 10 GW goal.
7 gigawatts.
Yeah.
Just from the first phase. Wow. So this isn't just planning. It's a full-on sprint.
Absolutely. A multi-billion-dollar immediate sprint to basically try and own the next decade of AI development.
Shows incredible commitment. But, something this huge needs more than just cash. It needs different kinds of expertise. That's where the partners come in, right? OpenAI, Oracle, SoftBank. What's each one bringing to this $500 billion party?
It's actually a pretty neat division of labor, kind of a specialized ecosystem.
Mm-hmm.
So OpenAI, they're the brains, if you will.
Okay.
They provide the cutting-edge AI research, the actual frontier models, the algorithms. They're basically creating the demand for this infrastructure because their models are getting so huge, they need custom-built environments.
And those models need the hardware, right? We're talking massive numbers of GPUs, graphics processing units.
Oh, absolutely. Tens of thousands, maybe hundreds of thousands eventually,
Right.
which leads to Oracle.
Right.
The GPUs need a place to live,
Yeah.
and they need a very complex software environment to run efficiently. That's Oracle's job. They provide the physical data centers, the cloud services platform, this specialized software stack.
So knitting it all together.
Exactly. The integration expertise to make tens of thousands of these chips work together as one giant brain. It's a massive engineering challenge.
Okay, so OpenAI does the AI, Oracle builds the house and plumbing for it. What about SoftBank? Just writing the checks.
Well, yes, they're bringing the huge financial muscle. The $500 billion in strategic capital is largely them. But the sources suggest it's more than just money.
Oh.
Their background is also heavily in telecom and connectivity infrastructure, especially globally.
Right.
All that compute power isn't much good if you can't get the data in and out quickly and reliably. So SoftBank helps build the financial and the digital highways for this thing.
Makes sense.
And you have to assume putting in that kind of capital gives them, significant strategic leverage down the road, a guaranteed seat at the AI infrastructure table.
It really drives home the point, doesn't it? Building the future of AI now seems less about just code and more about, well, real estate, power grids, and high
That's a
finance.
great way to put it.
So that leads nicely into the why. Why spend this unbelievable amount of money? You mentioned the compute race.
That's the absolute core driver. Every big player Google, Meta, Amazon, they're all pouring billions into scaling up their own internal AI infrastructure. Some people call these sovereign AI efforts.
Right, building their own capability in-house.
Exactly. It's basically an infrastructure arms race.
Yeah.
But the prize isn't just like a better search engine or a social media feed.
No, it's dominance in the next fundamental technology wave.
Precisely. If you want to train the next generation of truly powerful AI models, you simply need this kind of scale. If your competitor has 10 GW and you only have, say, 5 GW,
They get there faster.
they train models faster, they can explore more complex ideas, they potentially reach AGI milestones first. Right now, physical compute capacity is probably the single biggest bottleneck in AI progress.
So Stargate is kind of like an insurance policy against being left behind.
A very, very expensive insurance policy, yes.
Yeah.
Exactly.
And speaking of strategic moves, let's talk about where they're building. You said the first 5 sites are all in the U.S. That doesn't feel accidental.
No, not at all. It's absolutely strategic. That choice signals, pretty clearly, an alignment with the current geopolitical climate. We could call it the national security angle. By keeping these super powerful AI development hubs inside U.S. borders, the project kind of addresses governmental concerns about control and oversight.
Concerns over who ultimately controls this potentially transformative technology.
Both control and maybe regulatory access, yes. It lets the U.S. government potentially keep a closer eye on things, and perhaps more critically, it ensures that future AGI-level capabilities are developed under, let's say, American oversight.
Right.
It kind of draws a line in the sand, suggesting this tech is too important to develop just anywhere. We've seen this pattern before with other strategically vital technologies.
So the data center itself becomes a kind of national strategic asset.
In a way, yes. But that asset needs components, right? It's useless without the chips. How does this massive project connect to the broader AI supply chain, which is still pretty dominated by, well, NVIDIA mostly?
Yeah, good question.
The connection is absolutely critical. It creates this really interesting dependency loop. Stargate relies entirely on getting huge quantities of the most powerful chips, mainly from NVIDIA.
Okay.
And the sources actually point to how tight that link already is.
Yeah.
There's talk of a $100 billion investment deal that already ties NVIDIA closely to OpenAI.
$100 billion
Yeah.
just for chips on top of the Starbait budget.
It seems that way, yes. It shows you can't separate the physical infrastructure, the buildings, the power from the specific chips you put inside them.
Right.
And you can't separate the chips from the AI models being run on them. It's all interconnected.
So getting enough of those top-tier GPUs before anyone else, that's a huge challenge in itself.
Probably the most immediate and expensive bottleneck for Stargate, yes. Securing that supply chain is absolutely paramount. It's this complex dance between money, hardware, and AI ambition.
Okay, so we've talked about the scale, the partners, the strategic reasons. Let's shift to the implications. What does a project like this actually do to the world, starting with maybe the economics on the ground?
Yeah, it's interesting. The sources point out this kind of paradox.
Yeah.
On the one hand, Stargate is projected to create a lot of short-term economic buzz.
Not jobs.
Exactly. Something like 25,000 on-site jobs for construction, operations, maintenance, plus all the indirect growth in the areas where these massive centers get built.
Sounds good for those local economies.
It does initially.
Yeah.
But here's the tension. Job creation versus the potential for automation down the line. While you need thousands of people to build and run these centers in the short term, the very AI being developed inside them, the AGI systems Stargate is designed for,
are intended to automate potentially millions of other jobs across the economy.
Precisely. So we're hiring people to build the machine that might eventually make their neighbors or even their own jobs obsolete. It's a really fundamental conflict in developing this kind of powerful technology.
Strange feedback loop.
A very potent one that society is really just starting to grapple with. And that brings us back to the physical demands, especially the environment. We mentioned 10 GW of power.
Yeah, equivalent to millions of homes. That can't be easy.
No. It raises immediate, very serious questions about sustainability.
Yeah.
Where does all that electricity come from?
Right. Are they building 10 new power plants too? What kind?
That's the multi-billion-dollar question, isn't it? The energy demand alone will massively strain existing grids. It often means needing dedicated new power plants or huge upgrades to transmission lines.
And cooling. All those chips must generate incredible heat.
Astronomical heat. Cooling these facilities is another gigantic challenge.
Mhm.
It often requires enormous amounts of water. So suddenly, reliable access to massive amounts of power and water become the primary logistical and environmental hurdles to actually hitting that 10 GW target.
So energy and water constraints could actually limit the pace of AI development.
They absolutely could. And if you connect this huge resource consumption to the bigger picture, you see another worrying trend emerging: the centralization of power.
Meaning?
Well, when only a very small number of players, those with the kind of $500 billion budgets we're talking about, like this OpenAI, Oracle, SoftBank group, can actually afford to build and control this essential compute infrastructure.
Locks everyone else out.
It severely limits competition, yeah. What happens if a smaller AI startup or maybe a university research lab has a brilliant idea for a new model?
They can't afford to train it.
They likely can't, not at the frontier level. They become completely dependent on the goodwill, the pricing, the access policies of the Stargate Consortium or one of its few rivals like Google or Meta.
So innovation doesn't just depend on bright ideas anymore, but on access to these ultra-expensive centralized resources.
That's the fear. It potentially restricts not just competition, but the diversity of approaches, the diversity of who gets to shape this incredibly powerful technology. The barrier to entry isn't genius. It's getting prioritized access to GPU clusters and the power grids to run them.
And that kind of centralization must have global ripples, too.
Absolutely. If we summarize the global outlook, Stargate basically cements AI infrastructure as a major point of geopolitical competition. It's not just business rivalry anymore.
How so?
The sources draw a pretty clear line here. Think about how strategically vital things like oil reserves or rare earth minerals or maybe nuclear technology were treated in the past.
As national security assets.
Exactly. Compute power for AGI is becoming that kind of asset. The nations and the companies that control the Stargates of the world will wield enormous global influence.
So we should expect things like export controls, trade disputes, maybe even international agreements focused purely on access to compute.
It seems very likely. Stargate isn't just a data center project. It's signaling the emergence of compute as a fundamental resource of national and global power. #, outro. So if we try to boil down the core insight from looking at these huge investments, it really feels like this.
Yeah.
The main bottleneck slowing down progress towards AGI. It's not really about the algorithms anymore, not primarily.
It's the physical stuff.
It's the brute force, physical compute infrastructure. Whoever builds and controls the biggest, fastest, most efficiently powered data centers, the Stargates, they're the ones who will likely set the pace for frontier AI. They'll shape economics, and they'll shape geopolitical power for, well, probably decades.
It really has become a resource game, hasn't it? Shifting from just digital bits to concrete power and water. Okay, so if compute capacity is the new global power source, and hitting that 10 GW target needs the energy of millions of homes and vast amounts of cooling, here's the final thought for you to chew on. Which global resource will hit its limit first? Is it going to be the land needed to build these giant facilities? Is it the fresh water required for cooling? Or is it the sheer energy supply itself? Which one of these fundamental physical constraints will actually be the first to dictate the real-world pace of AI development, potentially putting the brakes on projects like Stargate no matter how much money is thrown at them? It's not just a tech challenge anymore. It feels like a global resource management crisis just waiting